thank you. Okay. Cool. I should have started.
Okay, Matthew started.
I should sing this.
Spin.
Never. First, I'm gonna remove some stuff. From here. Because it's second week, it's probably gonna get harder. It's still gonna be a random language, but I at least want to have a chance at proficiency. So I'm gonna remove stuff like Ruby or Bash or even Batch. I'm gonna also remove Go. I don't have it set up and it's gonna take a long time. Vulkan short. C, we can leave Java, C++, Python. Yeah, but let's leave this.
Okay, spin.
Do you wanna click it, Mickey? Yes. I'm sad. I keep forgetting to put. Okay, C++. So like C, but a bit worse. Thank you. Wow. Thank you.
Sure.
I should add it as a source because it has sounds, clapping and stuff.
You don't need it.
Thank you.
You have me.
Exactly.
Okay. Let's continue. Lulu. Oh, that's what I'm thinking.
Okay, let's see. So, what is it? We are doing problem number 8. We have 4.5 hours to finish it. Let's see. Okay. Haunted wasteland. You're still riding a camel across desert island when you spot a sandstorm quickly approaching. When you turn to warn the elf, she disappears before your eyes. To be fair, she had just finished warning you about ghosts a few minutes ago. One of the camel's pouches is labeled maps. Sure enough, it's full of documents, a puzzle input about how to navigate the desert. At least you're pretty sure that's what they are. One of the documents contains a list of left-right instructions, and the rest of the document seems to describe some kind of network of labeled node. It seems like you're meant to use the left-right instructions to navigate the network. Perhaps if you have the camel follow the same instructions, you can escape the haunted wastelands. After examining the maps for a bit, 2 nodes stick out: A, and Z. You feel like A is where you are now. You have to follow left-right directions till you reach Z. This is format that defines each node individually. For example, RL. Starting with AA, you need to look up the next element based on next left-right instruction in your input. In the example, starting with AA and go right by choosing the right element of AA, CCC. Then left means you choose the left element of CCC, ZZZ. By following the left-right instructions, you reach ZZZ in 2 steps. Of course, you might not find ZZZ right away. If you run out of left-right instructions, repeat the whole sequence of instructions as necessary. RL means RL. Okay, enough. Okay, this seems easy enough. I can.
I see.
I don't want to see that. Do I want to use Visual Studio for this, actually? Yeah, why not? No, I'm not gonna tweet, thank you very much. Visual Studio. Hopefully on the wrong screen. On that screen. It's the wrong screen. Again, I need to.
You don't get to be into that.
Yes. That's perfect. I'm just gonna remove this from this. Sure. Let's go into here. AdventOfCode 2023 AOC 2023, and then I'm gonna create a new project. Do I care enough? No, fuck it. We're just doing it the old-fashioned way. I'm gonna do day 8 It is day 8 actually. Let's see the day 8. Or here. Anyways. Let's see what it is. So we have main TPP. And put. Okay, let's just do
For bread.
copy that slash the yesterday 7.
Fireside before. Do you think that the 11 votes are unfeasible or something?
I'm gonna go to CPP.
You were showing my thingy, and I
Run compiles instead of GCC we do G++. CPP. I'm guessing everything else is gonna work the same.
Really? Oh fuck.
We're just gonna just remove everything. I'll remove this. Remove this. STB CL. Hello. Oh, that's just
That's Jeffrey, right?
standard out.
Jeffrey!
Let's see on TPP files.
No, I haven't talked with him. Gee,
STB CL. That can't see out for fuck's sake. Remember for standard input output, I think. iOS Genius.
Oh, what do you need?
Select fix.
Question.
Let's see. Check this stuff.
See it.
G++ should work. Okay, just to be sure. User bin plan user bin G++. G++.
Jesus Christ. But yeah.
Okay, that's all. That seems to work. What the fuck? No? Let's see. Let's /run.
What about me? Do you mind that? Have I helped you with anything?
Build that you wanna not run it. Just build. That's because I don't pass anything. I'm a stupid fuck. Don't.
Did you hear?
Okay, I'm back to the stream. Anyways, let's see. We have, okay, we're gonna remove the check.
Thank you.
Okay,
extra work thing.
Okay, and that's good for us. How many? How many steps to reach the ZZZ?
Yeah, do it right now. Do it right now.
6 seconds. Okay, this one takes 2. This one takes 6. I don't like how there's multiple. Read file line 5. Line 6. Shit, plus. Yeah, let's do if stream.
Hell yeah. So you're finished now with that.
F
Yes.
stream, F stream, F stream, F stream, file. That's just the
I'm a bit dense, so I'll ask a stupid question, okay?
let's
Because you submitted your proposal now, that means you're not waiting for input from your dad, which means you can publish your proposal as well now.
stream stream and string in file. It's just called file because that's what it is. Line. Okay, so this is the line. We have the line. You can do if first line, if master person. Like let's line.
Wait, listen. If
Okay, it does pass the new line. Yeah, let's see. We have.
then you don't have to think about it. Please, will you do that?
Let's see. So yes, we have nested the string steps.
No.
You can probably do that.
Lol.
The string steps. We hit out, and then we can. Can I pass?
Still yours.
Why the line?
Yay! Let's
They're making the line different input. That line.
I know.
No pointer. Huh?
Okie dokie.
Oh, PTR. No.
Maki,
Yes.
I love you.
To.
You're the best.
Okay, so this is the route. Okay.
Listen.
Yes. Yes.
Look into my eyes.
No.
You're the most beautiful, and I love you so much.
Me too.
And I'm here for you.
Thank
Okay?
you. Yes.
Whatever you need.
Thank you. No. Relax. Not with you. Manya. Okay, line here, and then we have track. And then we have left, which is okay.
What did you say?
The string left and
Right?
the string right. And this one also.
Send me to what?
Okay, thank you. Is it always three name? Real letter ones. Yes, it is perfect. I can unclip them. Okay. That. I have std map of string to directions.
Oh,
Yeah, that was supposed to be shown to him.
sorry,
Okay, yeah. Oh yeah, that was great. Then we get the line. Then we do state auto, I don't know. Name is equal to sub string 0 3. Is this length or what? Position and yeah, 3, and then we do again also the same, so I can just hard code stuff. Auto left is equal to right 3, then we have something 3. So 0 1 2 3 4 5 6 7 8 9 10 11 12 7 and 12 and 12. That way. And then directions insert. We make their name right. There. Yeah. Okay. Where is the channel file? Utility, it's in. Okay, it's literally utility.
I bored my cat.
Purchase the arguments. Okay. Huh?
The cat stood up with my singing.
Your cats. Lol. That's exactly how it would be done. And then we can do for while through. Maybe I can do just the amount of steps. For in size steps 0 steps plus. Okay, while sure, why not? Size yep. See, start everything first. Just sign off. Size D. Size lib. DSTD lib.
When I'm bored, I just sing.
I see that.
Do you?
No, of course. That's all. Step plus. And then is the current is equal to AA.
Oh.
Number of steps. Current name. Okay. And then step. I'm gonna parse the step, maybe it will be smarter to just pass it left, right. So And it's that it doesn't matter. It's a simple calculation right here. Steps at a number of steps percent step percent. Okay. Okay, let's call this intro. And then we can do size the number of instructions is instructions.size. After we read it, of course, and then we can do percent that. If this equal to left, else, and current name is directions at left, right, and also this is instructions. No, this is
Where are you going?
if I break
From another computer?
How
many do you
so the number of step and roof steps and one.
You fucked me right off. I asked you out of genuine interest, and you said the reasons.
The name right.
You won't push it? Push it, push it. We don't care, push it.
There's another line for it. Yeah, that's fine with that stuff. If 100 break that's the break the break. Okay, so
they're better for you. Get mad at me.
Is and name and
Hell yeah.
and what and instruction. Yeah.
That's a short pass.
I mean, I know both of them are not going to be longer than, so let's just try that. Introduction left B E. A left.
Okay, cute.
How many days? One. Hello. How you do? I'm sure you can find some activities to do. Do you wanna watch me do this stuff? And hopefully be fast as fuck. How many did it say? 6? 6. I press button. Thingy, right? Okay, I think I finished the first thingy magic. I just wonder how long it's gonna take me to finish the second part. Well, that's what happens when you get good languages. If I had gotten C, I would have cried for a long time, because I got C++, which means I got a lot of libraries, like for example a map, with a map implemented, which means I can just search through a map, which a lot of this was literally just searching through a map, so I would have to implement a map myself, and arrays, and strings, and everything. I don't want to do that, so I didn't.
I think the hardest type of advanced coding.
I don't know. Let's see. Now we have part 2 to finish. Okay, let's read. Do you want to listen to me? For 2 minutes if you want to see.
Yes.
Okay, the sandstorm is upon you, and you aren't any closer to escaping the wasteland. Hurrah! Oh, I have viewers on YouTube. That's good. Cool. Hello, viewers. I don't know if I ever have it. That's cool. Loser. Fight. I'm joking. Thank you. Anyways, the sandstorm is upon you and you aren't any closer to escape the wasteland. You had the camel follow the instructions, but you're barely left your starting point. It's going to take significantly more steps to escape. What if it isn't mapped for people? What if it's mapped for ghosts? Are ghosts even bound by the laws of space-time? Only one way to find out. After examining the maps, I don't know how to read, a bit longer, your attention is drawn to a curious fact. The number of nodes with names ending in A is equal to the number of ending in Z. If you're a ghost, you'll probably just start at every node that ends with A and follow all the paths at the same time until they all simultaneously end up at nodes that end with Z. What the fuck does that even mean, bitch? Here there are 2 starting nodes, 11A and 22A, because they both end with A. As you follow each left-right instruction, use that instruction to simultaneously navigate away from both nodes you're currently on. Repeat this process until all of the nodes you're currently on end with Z. If only some of the nodes you're on end with Z, they act like the other nodes and you continue as normal. In this example, we follow the process as follows. So we start at both of these, left both. I started here, but I have to continue until they're both Z. How about... Fuck you. Test 2. Test part 2. Okay. This is not good. And this is what we call usually fuck. In this. Fuck me. How does the puzzle input still looks the same? So I have to find all of the inputs and then just go through the array of them.
I'm listening.
Thank you, dear. Thank you, dear. No, I don't mind. The factor start steady string start current positions. How many steps does it take? Okay, cool. يعني بتذكر كده. I'm gonna started. And I'm gonna be continue doing and then like algorithm yeah, let's do that. So we start with this if name and they're all 3, right? So I can do name it to Z, no A, push back, name, passwords. Yes. Then for each, for auto reference name, no, actually for int size d to 0 is less than size plus at I is equal to attack. And then we have to loop through all of them again. I mean, bool r whatever, I don't know. R O do finish. If current position at I at 2 near Z. Oops. But I think it would actually be faster to do this. Because we don't expect them to do. Actually, let's try this, and I don't think that's gonna change it. I don't think like it's gonna change. If finished break, that's not gonna. That's not good. Left, that means it will go on the left and or the right. Yep, 6 steps. Yep. How much do you bet it's gonna take? What do you bet? How long is it gonna take? I hope faster, bro. I hope a lot faster, yeah. This one was 6. Oh, easy. Left, right. I almost restarted it, but how many steps did it take before on your nodes that end with C? Oh, that sounds fun as hell. Now give me a thought. I killed that thing, magic. Thank you. Can you throw that in the trash? Because it hasn't been long. I just want to know. I'll print this out. starts size the number of positions. Because why not? Then I'll save it here. Or just 6 positions. So what the fuck? I thought it would be like a million. It feels incorrect. Have I messed something up? How many are like not that? Hey. Z. Well, that's cool.
Ono kad kažu da fluorid nije štetan u vodi, dok na pastama za zube piše da pozoveš kontrolu trovanja ako progutaš pastu.
No.
Should mouth after pasta?
Fine.
Yeah.
I don't know if you're right or not.
Please be careful.
I'm gonna try a faster version, which I think is actually gonna be faster. And this is where good math comes in. So you have to find the number of times where they all find the correct thing, which is gonna be hard. But you can do 6 different ones. Find how long each one takes, and then you know what I can do. I can multiply the number of times that they take. Fuck. Ah, shit. I feel like he. Boop. It feels incorrect. It feels incorrect. He must have done something. I'm gonna try that one. Though now I don't believe in it all that much. Because he seems the writer of this puzzle seems smarter than that. It seems like he would think of that and then add something else, where you don't end up at just one, end up at multiple ones. I'm gonna try this one. I'm just gonna do all of them. The first C steps, and then I'm gonna do number positions, and then per position. I'm gonna try it and be like very happy it works. It's not gonna work problem. So 0, 1, 2. Okay. Easy. Number of positions at I. Number of steps. Which number of finishes plus and finish a nice number of finishes to number of positions. Number of positions. If it is the and Ne możesz w position.
Just look at this. There.
No, they're doing like the slug bot. Oh, that's not normal though.
What she did.
She killed her. Absolutely, she killed her. Judo.
Bro.
Options. Is from option or optional? That way, if it's not set, I can set it, and if it is set, we just keep it. If has value. Only if it doesn't have value, we're gonna do this. Up. There. Doesn't matter. Let's set value, or what is this for? Create option. Should I set it though? I know I set it here, so I just look at this. This I want to remember how the this is how something works, and I know it's been used here, so I know where to look at least. Yep, here. Okay, we just have to set. I guess they overload. Yep. Finish it. So let's do for size di is equal to 0, I is less than number of positions plus out. Let's do number subsequent position of tile value. Three and 1, and then I can do a size the sum 1 times equals value, the value sum. Let's see, maybe this one finished. Wait, yeah, that's cool. So run to run and shift that back. 2.5 or something. Run LF2. Let's try 3 or something maybe. 5. Compile 2.5. 5. Just crashed everywhere. Set JSON. Okay. Compile. That was 17 then. I feel that. Except. Let's see. NZD neće zajednički djelica. The greatest common divisor, also greatest common factor of two numbers is a large number that divides them both. Better in us. Common is the least common multiple, smallest number that two or more numbers can divide into even. Both syllables. Either literally an LCM. Least common multiple. And this is the type. Okay. Least common multiple. X numbers. This least common multiple. Greatest. And then we can, okay. That's right. I almost closed the wrong one. I was about to kind of. I hate hearts. Int results. Emulate vector of size the values, number of positions, values, I is value, numeric path, numeric accumulate. So I'll start again. You can also pause this. I need that. So then I don't know how it would think I want that. That would one. Let me pass this. I close it. Result. I want size times size t size t. Let's see. I don't know which one seems work. This one is even bigger. So that's obviously then incorrect. I don't fucking know what to tell you. LCM arguments. Oh, can I actually use LCM? Please tell me I can use LCM. Please. I thought it was only 2. Maybe there's more. Oh, that's a lot. It's fucking. LCM. The LCM. Fuck. Shush. LCM integer must be bool, must not be bool. LCM implementation is M over GCD. So it's not context provided and support. Fine. Cool. I love those things. 1, 2, 3. It's nice that just going to list intent. Yeah, that's the list. Wait, per and then the rest for size I equal to 1, I is less than number of positions, I plus plus. Oh, hello. Didn't so it's good. I don't know how to read. I don't a viewer. Hello. I'm working on the AdventOfCode day 8.
Hello!
I have a solution running, but it's very slow. So I'm trying to find a solution that's not as slow and see if it works. And hopefully it does. And just steady, I'll see. Let's try it like this. How are you? I don't. Maybe he's not here anymore.
Hello? Do you, Roger?
Nope, he left. Well, anyways. Size. LCM. Is number of positions. Is actually values at 0 and then steady LCM values LCM and what now? LCM and values at I. Let's see. This looks like a number it could be. It could make sense. Let's try. We are trying to big brain the solution. Maybe it's gonna work, maybe it's not gonna work. I was correct, it worked. Fuck you. No, it was 0 seconds because I did it the other way. So you were not correct. I was correct. I was not correct, which was better than what I thought it's gonna be. So what I did, I'm gonna now tell you. So listen, what I did is I need to save the screenshots for later. So just a second. I need to change the thumbnail. I forgot to change it, so I need this. If I'm just gonna send it to you. Okay, perfect. So the challenge, I saw it was taking a long time. Okay, I was like, that means I'm effed. So I was like, well, what can I do? So I was like, well, I know that what I need is to find the number of steps for each of them to reach the end, but they have to do it at the same time, otherwise they continue rolling. So I was like, well, maybe we can do NZT. So I was like, let me find for each one of them, because that's probably not gonna be too many steps. Let's find for each one of them a step, and then just do my NZT or LCM in this least common. What was the name? LCM, least common multiplier. So I found the least common multiplier, and that was correct. I thought he was gonna be an asshole and make it so you didn't get exactly that. So for example, you could do it for example, for the first start, you could end it at third point or at fifth point. So that would be at 6th and 10th as well. Which means he would fuck you over. But no, it's just literally a loop, thankfully. And I'm so thankful for that. See the difference. More islands are being built up. That's good, that's good, that's what we call progress. Fuck yeah. What are you doing? Do you wanna eat? I'm gonna put the oven on. I'm gonna be right back, mi amigos. Whoever, if anyone is here. I mean, I know you are here. No, you're not, I don't see you. Lies and stuff. Okay, cool. Anyways, we finished. BRB. BRB, let me just change this one to BRB. Finished. Puzzle. Finished puzzle, be right back. Small break. This, and then I'm gonna set up this. Scaling, blending. Where is transform? Transform. Unlock it. I'm smart. Center. Now lock it again. Transition. Probably. Hello. Hello, I'm back. The streamer is back. I have to do some stuff. I lock this layer so I can't remove it. Let's do this. Outer, not blinds. What the fuck was the name? Outer wilds. Okay, I need to save this game. Outer wilds. Outer wilds. I'm gonna leave this running, and I just want to see how long it's gonna take for it to finish. I didn't time it, sadly. Sad. Outer wild. Outer. Let's say that here.
I was in this weird state. And I'm just...
That means you should relax, dear. Relax.
basically ruminating over nothing.
You're not... What? You're being a room over nothing. Vroom, vroom. Vroom, vroom, vroom. Oh god, I'm stupid. Anyways, I'm so sad. I haven't timed this C++ program. It's probably gonna take a long while. This many. So the result is this, which is, I don't think if you can guess a lot. It's
Like,
so this is thousands, million, billion, just a small 14 trillion guesses. Yes, please. See this, and then we can go. The 8, is it the 8? Yes. Warm greetings. From
so
it's smarter.
you were not wrong. Really?
Since the instruction. Yes. LCM. I'm so glad that there was an LCM directly embedded into this because I sucked at it.
Hell yeah. Get that.
Simple inputs.
You deserve every cent. Okay? Do you know how
Fold. There's
so much shit throughout it? Oh my god. Like, you should have, you know?
Of course, this next times the sun and back kind of, yes.
And then
Okay,
all of your free time.
20, only 14-ish billion steps.
Raise.
A to Z.
Like, imagine how you feel.
Brute force today. But yeah.
I suppose.
I feel like. Does everyone get a different input?
The thing you take.
Does everyone get different input? Advent of code. And different inputs?
You shall reap the fruits of your labor.
Multiple. Aha, cool. So I guess it's just a random amount. It goes into making these inputs similar enough to be fair. The humans they will be full. So then two will be fine. Yeah, that's cool. Still for
You're such a good person.
achieving a solution, the actual code that gets you to the hard.
Should I say this?
That's so cool. I like it, so I should not share my input code. After the fucking length of the input code, I don't think you can see the input. Neither can I, and if you care enough, so cool. Did you know? But something I found out right now. Everyone gets different inputs.
Oh.
Or there's probably groups of inputs, you know? and they like to, so it's harder to cheat.
Yes.
So, princess, now I'm good to this. Good.
Give yourself a pat on the shoulder.
Wait care to see how long it's gonna run. Fuck. You're fancy people, don't do hard. That was 100% sure it's gonna be. Like, nope. I was gonna cry. I'm gonna save slot summer so I can remember to write about it. They really thought that the input would be as such that we couldn't just do Asia? Sim. But that would be too hard. Anyways, I said that, and by I said that, I'm gonna message that to my girlfriend, and then I might at some point read it to put it somewhere. Anyways, as I said, now we work on continuing. Let's continue learning Vulkan and C++. In AdventOfCode Day 8. Save that. Hello and goodbye. Thanks. I'll do second reading name. So let's continue learning Vulkan. Finish. Oh, this is perfect. Finished AdventOfCode Day 8 Discord, which if anyone is interested, I mean if there was anyone. Either. Denise is cool. I also take time to learn to read. You know, please get my thank you. I got flashbang. I don't like that. Yes. 10,000 times.
Yes.
You rich, kinda rich, huh? 10,000 times would be 3, 6, 7, 8. Oh. 100 million.
Huh?
100 million.
Yes.
100 million of the currency you need.
Yes.
It's 30 million.
So that they have the job forever. Can do whatever they want.
Cool. I guess we broke motherfuckers can only imagine those numbers, eh? Yeah. What you call me?
You don't need forever then.
What?
That I'm a broke mother.
No, I said I. Like we broke motherfuckers because you're so rich you can just spend 10 million, 100 million, I'm sorry. So we broke motherfuckers never gonna learn how that works, eh? I see how it is. No. Don't worry. We now work on the gaming.
Hell yeah! You do.
And by game I mean G of a game. Can I make this automatically open somehow? Okay.
Fine.
Right. Oh shit, there's ban shown right now. Game debug. Debug of the game type. Yesterday we had, I cut the stream short in quotation marks. we just just a second. Hello, chat. Can you go ahead and speak with the chat?
Chat, how are you? I can't speak right now because I'm very unwell. I hope you all are great and amazing and that you have a lovely day. Okay, here is the video. But that sound is just playing in my head and it sounds really constant.
No problem. I forgot to take the gun out.
Oh shit!
Lies.
Don't scare me like that.
No, I gave you adrenaline, so you're
Thank you.
don't know everything just for you, and not because it's funny as well. What's the sound?
This.
Don't listen, chat.
Not this.
Can you? But someone doesn't know you and then something. That's a creepy ass sound. Please don't show it to me.
That just stuck in my head.
If that was stuck in my head, I would change it, brother. That's fucking creepy as fuck.
You don't know me.
How many times?
15 minutes.
Is that enough? It was in freeze. 17. 17 minutes. What's wrong? This?
Yes. I mean, it took my medicine anyway.
When?
Now, right now.
Okay, it's gonna come to you. You just lay down. Tell him to put on some funny memes, the unusual memes, and watch that. Either he puts it on or you put it on right now. Can he put it on? You're just anxious or something happens, don't worry. To me too. I'm thinking it happens to everyone. You just have like shit mood. You can get out. You will get out, don't worry, okay? I see, don't worry, okay? Relax, okay? Does he hear you?
Yes, he can.
Are you not muted?
I'm not muted. Why?
But he's not putting on the memes.
Huh?
He's not putting on the meme. Oh yeah, but he's not doing it. That's what I'm telling you. Yes, swap chain. We created a swap chain yesterday, if I remember correctly. For easier security, swap chains and swap chain images. Yep. Let's go to the next chapter. Oh, it's on Discord. This is the weird ass thing. I'm sorry, I didn't know this was the Alpha Telegram. Who's my strong? Call me strong. Relax, please, okay? Who's that? Pokemon! Me and you! Us together! I feel great. That was the funniest video. Like, what the fuck? Please stop. Okay, image view. To use any VK image, including those in the swap chain, in the render pipeline, we have to create a VK image view object. An image view is quite literally a view into an image. Thank you. It describes how to access the image and which part of the image to access. For example, it could be treated as a 2D texture depth, 2D texture depth texture without any mapping levels. In this chapter, we'll write a create image view views function that creates a basic image view for every image in the top chain so that we can use them as color targets later on. First, add a class member. I'm gonna do this as always. Oh. No. As we add a vector of VK image view or VK image view and create image view function. Let's create swap chain, we create image view function, then we do this around here. Let's see. The first thing that we need to do is resize the list with all of the image views. Okay, makes sense. Swap chain views, image views, resize. What the fuck? Swap chain image size. Thank you. Then we look through all of them. For size D is 0, I is like swap chain images size I plus, and then we use create info. I'm just gonna copy paste that. That's too long for me to just write. Swap chain images. Okay. The first parameter is straightforward. Yeah. The view type and format field specify how the image data should be interpreted. The view parameter allows you to treat images as 1D textures, 2D textures, 3D textures, and cube maps. We just want 2D textures and not cube maps, but it would be funny if we use cube maps. Cube maps are for something else. I don't remember what it is. But there's for something else. That's what I do remember. Now, the components field allow you to swizzle the color channels around. For example, you can map all the channels to red channel for a monochrome texture. You can also map constant values of 0 and 1 to a channel. Yes, you'll stick to default mappings. Cool. 0, 1, 2, 3, 4, 5. Stick. F. Cool. The sub-resource range field describes what the image purpose is and which part of the image should be accessed. Our image just will be used as color targets without any mapping levels or multiple layers. So let's see all the things. So we have aspect mask, it's a color, no bitmaps, one level, 0, yes, it's a layer 0 and layer count 1. I guess we only create one thing. If you're working on a graphic 3D application, then you would create a swap chain with multiple layers. You could then create multiple image views for each image representing the view for the left and right eyes by accessing different layers. Cool.
Oh no.
Creating the image view is now a matter of calling the create image view. And then swap chain is high. If not if you want to create image view. Unlike images, the image views were explicitly created by us, so we need to add a similar loop to destroy them again at the end of the program. Very true, vanilla. Main loop, I don't know what the fuck I'm doing. Okay. As an image view is sufficient to start using an image as a texture, quite ready to be used as a render target just yet. That requires one more step of indirection known as the frame buffer. Also, he has set up the graphics background. Holy shit, that's so much fun. And now, on to the next chapter. Or group of chapters. That's how you sleep, that's why your Flucho don't work. Anyways, let's see. I need to open codes, Vulkan game. Add image. Add image here. I wanna commit all of this nicely, so I have the code, the differences and everything. So if I, for example, want to add image views or something, I can look at the code history. Maybe. Or just look at this tutorial. I don't fucking. Exactly! On the fucking X. Fucking. What do you mean the fucking house? There's fucking house all over the place.
Please, in a new tab. Please. Play fucking islands. Please. Fucking islands. Islands.
That's the funniest fucking video on the internet, I feel like. What the fuck? It's quite true. What fucking island are you talking about? Fucking islands all over the place. Yes. That's certainly. Oh my fucking god. There it is. Who the fucking islands? Over the course of the next two chapters, we will be setting up a graphics pipeline that is configured to draw our first triangle. The graphics pipeline is a sequence of operations that take the vertices and the textures of your meshes all the way to the pixels in the render target. A simplified overview is displayed below. So I go from input assembler to a vertex shader to a tessellation thingy to a geometry shader to rasterization to the fragment shader to the color blending and then a fluid buffer. The input assembler collects the raw vertex data from the buffers you specify. May you also use an index buffer to repeat certain elements without having to duplicate the vertex data itself. The vertex shaders is run for every vertex and generally applies transformations to turn generally applies transformations to turn a vertex position from model space to screen space. It also passes per vertex data down the pipeline. The tessellation shader allows you to subdivide geometry based on certain rows to increase the mesh quality. This often is used to make surfaces look like brick walls or staircases look less flat when they're nearby. How? The geometry shader is run on every primitive triangle line point and can discard it or output more primitive than came in. Yeah, this is similar to the tessellation shader but much more flexible. However, it's not used much in today's application because the performance is not that good on most graphics cards except for Intel's integrated GPUs. Lol. The rasterization stage discretizes the primitives into fragments. These are the pixel elements that they fill up on the frame. Any fragments that fall outside the screen are discarded and the attributes outputted by the vertex shader are interpolated across the fragments as shown in the figure. Usually the fragments that are behind other primitive fragments are also discarded here because of depth testing.
What's that?
The fragment shader is invoked for every fragment that survives and determines which frame buffers the fragments are written to and with which color and depth values. It can do this using the interpolated data from the vertex shader, which can include things like texture coordinates and norms for lighting. The color blending stage applies operations to mix different fragments that map to the same pixel in the frame. Fragments can simply override each other, add up, or be mixed based upon transparency. Stages with green color are known as fixed function stages. Fixed. So input, rasterization, and color blending. These stages allow you to tweak their operation using parameters, but the way they work is predefined. Cool.
Decomposing it, and then
Stages with an orange color, on the other hand, are programmable, which means that you can upload your own code to the graphics card to apply exactly the operations you want. This allows you to use fragment shaders, for example, to implement anything from texturing and lighting to ray tracers. These programs run on main GPU core simultaneously and to process many objects like vertices and fragments in parallel. If you used older APIs like OpenGL and Direct3D before, then you'll be used to being able to change any pipeline setting at will with both like GL blend func and OM set blend state. The graphics pipeline in Vulkan is almost completely immutable, so you must recreate the pipeline from scratch if you want to change shaders, bind different frame buffers, or change the blend function. Holy shit. The disadvantage is that you'll have to create a number of pipelines that represent all of the different combinations of states you want to use in your rendering operation. However, because all of the operations you'll be doing in pipeline are known in advance, the driver can optimize it for it much better. Makes sense, I guess. Is it? I'm going. Yes, okay. Some of the programmable stages are optional based on what you intend to do. For example, the tessellation and geometry shaders can be disabled if you're just drawing simple geometry. If you're only interested in depth values, then you can disable the fragment shader stage, which is useful for shadow map generation. Cool. Is that a tutorial here? No. Okay. I'm gonna this for myself here. I just send you stuff like a thank you. I'm just sending you stuff, you don't have to do that for me. In the next chapter, we'll create two programmable stages required to put a triangle onto the screen, the vertex shader and the fragment shader. The mixed function of configuration like blending mode, viewport rasterization will be set up in the chapter after that. Final part of setting up the graphics pipeline in Vulkan involves the specification of input and output frame buffers. Create graphics pipeline function that is called right after creating image views in Vulkan. We'll work on this function throughout the following chapters. Cool. Let's close all of these. So many functions, brother. Create graphics pipeline. Next chapter. Okay. Because my dinner is gonna be ready in 20 seconds, I'm gonna go ahead and pause this. Duplicate, paste, duplicate. Smaller. Rename. And then we have our dinner. Dinner. How do I spell dinner? How many ends? The in and a arrow. I hope. Because we're gonna be eating now. Yeah. Center to screen. Runs. I'm back. There we go. Now let's do shader modules. Fixed function header passes conclusion. Okay. Let's see, so we're doing shader modules now. Vertex shader, fragment shader, per vertex coloring, compiling the shaders, loading a shader, creating the shader modules, and then shader stage creation. Big words for me, I think. I'm gonna see this. Directors. Yeah, let's see. Anyways, unlike earlier APIs, shader code in Vulkan has to be specified in bytecode format as opposed to human-readable syntax like GLSL and HLSL. Bytecode format is called SPIR-V and is designed to be used with both Vulkan and OpenCL, both Kronos APIs. It is a format that can be used to write graphics and compute shaders, but we will focus on the shaders used in Vulkan graphics pipeline in this tutorial. The advantage of using a bytecode format is that the compiler written by GPU vendors to turn shader code into native code are significantly less complex. The past has shown that with human-readable syntax like GLSL, some GPU vendors were rather flexible with their interpretation of the standard. If you happen to write non-trivial shader with a GPU from one of these vendors, then you'd risk other vendor drivers rejecting your code to a syntax error, or worse, your shader running different because of compiler bugs. With a straightforward bytecode like format like SPIR-V, that will hopefully be avoided. Here. The industry is open standard intermediate language for parallel computer. Standard parallel compute.
What the fuck?
Standard parallel intermediate representation or something. PRV.
Oh my god!
Cool. However, it is straightforward, yeah. However, that does not mean that we need to write this bytecode by hand. Kronos has released their own vendor independent compiler that compiles GLSL to SPIR-V. This compiler is designed to verify that your shader code is fully standards compliant and produces one SPIR-V binary that can ship with your program. You can also include this compiler as a library to produce SPIR-V at runtime, but we won't be doing that in this tutorial. Also, we can use this compiler directly via GLSL long validator TXC. We will be using GLSL-C, the TXC by Google instead. The advantage is GLSL-C is that it uses the same parameters format as well-known compilers like GCC and Clang. It includes some extra functionality like includes. A lot of them are already included in the Vulkan SDK, so you don't need to download anything extra. GLSL is a shading language with a C-style syntax. Programs written in it have a main function that is invoked for every object. Instead of using parameters for input, a return value as output, GLSL uses global variables to handle input and output. The language includes many features to aid in graphics programming, like built-in vector and matrix primitives. Functions for operations like cross products, matrix, vector products, and reflections around a vector are included. This vector type, the vector type is called vec, with a number indicating the number of elements. For example, a 3D position would be stored in a vec tree. It is possible to access a single component to remember like .text, but it's also possible to create a new vector from multiple components at the same time. For example, the expression vector123.xy would result in a vec2. The constructors for vectors can also take combination of vector objects and scalar values. For example, vec3 can be constructed with vec2 of 1, 2 and just the scalar 3. As the previous chapter mentioned, we need to write a vertex shader and a fragment shader to get a triangle on the screen. The next section will cover the GLSL code for each of those, and after that I'll show you how to produce two SPIR-V binaries and load them into the program. Let's see. The vertex shader processes each incoming vertex. It takes its attributes like world position, color, normal, and texture coordinates as inputs. The output is the final position in clip coordinates and the attributes that need to be passed on the fragment shader, like color and texture coordinates. These values will then be interpolated over the fragments by the rasterizers to produce a smooth gradient. A slip coordinate is a 4-dimensional vector from the vertex shader that is subsequently turned into a normalized device coordinate by dividing the whole vector by its last component. These normalized device coordinates are homogeneous coordinates that map the frame vectors to a -1 to 1 by -1 by to 1 coordinate systems that look like the following. Okay, makes sense. You should already be familiar with these if you have dabbled in computer graphics before. If you have used OpenGL, you'll notice that the sign of y coordinates is now flipped. The z coordinates now uses the same range as it does in direct 3D from 0 to 1. For our first triangle, we won't be applying any transformations. We'll just specify the positions of 3 vertices directly as normalized device coordinates to create following shapes. Huh? Don't worry. We can directly output normalized device coordinates by outputting them as clip coordinates. That's the Confederate flag.
That's the bad flag.
Yeah, Sammy, yes.
The bad people flag, right?
That's the Confederate flag from America.
The ones who like planes?
I think so, yes. I don't think I... From the vertex shader, with the last component set to 1. That way the division to transform clip coordinates to normalized device coordinates will not change anything. Normally these coordinates would be stored in a vertex buffer, but creating vertex buffer in Vulkan and filling it with data is not trivial. Therefore, I've decided to postpone that until we've had the satisfaction of seeing a triangle pop up on the screen. We are going to do something a little unorthodox in the meanwhile, include the coordinates directly inside the vertex shader. Code looks like this. The main function is invoked for every vertex. The built-in GL vertex index variable contains the index of the current vertex. This is usually indexed into the vertex buffer, but in our case it will be an index into a hard-coded array of vertex data. The position of each vertex is accessed from the constant array in the shader and combined with dummy z and w components to produce a position and clip coordinates. Built-in variable GL position functions as the output. Fragment shader. The fragment that is formed by the from vertex shaders fills an area screen with fragments. The fragment shader is invoked on these fragments to produce a color and depth for the frame buffer or frame buffers. A simple fragment shader that outputs the color red for the entire triangle looks like this. The main function is called for every fragment, just like the vertex shader. Main function is called for every vertex. Colors in GLSL are core components with vectors with RGB and alpha channels within the 0 to 1 range. Unlike GL position in the vertex shader, there is no built-in variable to output a color for the current fragment. You have to specify your own output variable For each frame buffer where the layout location is 0, modifier specifies the index of the frame buffer. The color red is written to this out color variable that is linked to the first and only frame buffer at index 0. Pre-vertex color. Making the triangle red is not very interesting. Wouldn't something like this, like the following, look a lot nicer? Yes, it would. We have to make a couple of changes to both shaders to accomplish this. First off, we need to specify distinct colors for each of the 3 vertices. The vertex shader should now include an array with colors just like it does for positions. Do I put the shaders here or out? Shaders. So we have our vertex. Vertex.glsl. Can you just vertex.glsl add let's open it in File Explorer. Fucker add and fragment.glsl F5. That's not what I want for sake. I wanna refresh this. How do I refresh? There, that's how I do. Okay, so fragment shader. So actually it's vertex first, fragment later.
Oh my god.
From vertices and then fragment shader just gives us the color.
What the fuck's it?
Because I hate how this looks in there. I'm just gonna open them in VS Code. Oh my god, they look much better. I said it's broken.
Oh no. Oh hell no. Oh no. Oh no.
Fuck matter. Prefer text colors. Parent triangle red is not very interesting. Would it be a bit better to get this? Yes, it would be. So let's copy paste this. Like this. So we have colors. 3 colors and starts from my red, green, blue. Then we just need to pass per vertex colors to the fragment shader so it can output their interpolate values.
Oh my
To the
god.
frame buffer. Add an output for the color to the vertex shader and write to it in the main function. So we also make this at location 0 out actually frag color. Then frag color is this. Then in the fragment shader we can have in actually frag color, and we're just gonna put frag color here and 1.0. The input variable does not necessarily have to use the same name. They will be linked together using the indexes specified by the location directive. The main function has been modified to output the color along with the alpha value shown of the image values for frag column will automatically interpolated for fragments between the three vertices, resulting in a smooth gradient. Compiling the shaders. Create a directory called shaders in the root directory of your project and store the fragments shaders shader.vert and shader.frag. Maybe that's better. Fragment. Shader. Frag. Shader. Okay. Shader.vert should be frag.
Flowers for all.
Parent to single cells.
It's a book.
No, let me.
I can record myself reading every day and send it to you.
Of a book. Why don't you just make an audiobook then?
Well, it is an audio.
What? What you're doing? You should absolutely.
Flowers
Sorry.
for all is an ode to people who have difficulties.
Can I not just use this?
Very low.
Yes, I can. That I shouldn't do.
It talks about how he was treated in life and stuff. And then
.SPV and flag.SPV. Replace both. Again, we don't need. This is just how we're gonna have it. It shouldn't have anything special there.
is
And the platform specific. And this two functions. So blah blah blah. Says you expect trailing out semicolon, for example, and then compiling. Okay.
either
Okay.
tisk or have low IQs, you know? And they have,
Okay.
if we're talking, and you know, just
I'm gonna forget.
majority,
We're gonna forget. We're gonna remove the semicolon here and let's see if syntax error unexpected right brace expected comma or semi. See? Smart people.
two,
I don't think we need a pause here though.
you know,
Unless we open it in a separate, but I'm gonna call it here. I'm gonna add it actually back. Yeah.
they have
And there are simple options since it is also possible to compare shader direction from your shaders. See which is library to compare. Loading the shader. Let's have it producing Spear V shader. It's time to load them into our program to plug them into the graphics pipeline at some point. So first write a simple helper function to load the binary data from the files.
well, that's gonna be me,
Okay, let's see.
you know? But like he said,
F3.
me,
Here we have file name, then you have 8, also known as something and then binary file, and this is I think from start. I don't remember, something like that. Yeah, start reading at the end of it. So we can see the size of file. Binary starting to read at the end of files that we can use to determine the size.
two,
To open a file. They can seek back to the beginning and read by all the data at once. Finally close and return the file. Cool. We'll now call this function from Play Graphics Pipeline. Shaders vert and shaders frag. Shaders are loaded correctly by printing the size of buffer by checking the amount of exercise in bytes.
the site can make you
So let's look specifically what's
to be exposed to the book,
Put an increase.
make to myself read through it and make it an audiobook.
And this, yeah.
And that's why you autism and non
File
ways of living.
is the
There is no right
and
way, you know?
let's run and see if it works. I don't think it's gonna work. I think I need to move the shaders. Cool.
Yep.
Oh, I don't need to move the shaders. Support. Even better. I can leave it there. I thought. See, it's 1552, and if I do it here, it's 572 and 1504. Perfect.
Like the KKK and shit.
So that works.
That's
I thought I would need to put it not in game but above. But I don't need to do it. Creating a shader module. Or you can pass the code to the pipelines when you have to wrap it in a VK shader module. Let's create a helper function for that. Can't wait to move all of this around. I hate doing it all in one file. This function will take a buffer with bytecode, the bytecode as parameter, and create a VK shader module from. Creating a shader module is simple. We only need to specify a pointer to the buffer with the bytecode and the length of it. This information is specified in a VK shared module create info structure. The one catch is that the size of the bytecode is specified in bytes by bytecode pointer is a Win32T pointer rather than a char pointer. Why? Who would do that? Who? Well, when you perform a task like that, you also need to ensure the data satisfies the requirements of Win32T. Luckily for us, the data is stored in a vector where the default allocator already ensures the data satisfies worst case alignment requirements. I don't know if I'm sure, but I don't trust that thing.
no.
Like at all. Yes. I don't trust it. Make a shader module. Yeah. Create the shader module. Save it. Say how to create shader module. And then we return it, I guess. Use creation methodology device pointer to the created infrastructure. Optional pointer. Blah blah. Interface creating the shader module. What did you do? What happened? And that's why I don't think, if you should have watched a sad movie right now. That's good.
It's just
You don't need to introspect, don't worry. Shader modules are just a thin wrap around the shader bytecode that we previously loaded from a file and the function defined in it.
I can't get
After with the code can be freed immediately after creating shader module. Forget. I mean, it's gonna be itself. Shader module is just in wrappers. The compilation and linking of the SPIR-V bytecode to machine code for execution by the GPU doesn't happen until the graphics pipeline is created. Means that we're allowed to destroy the shader module again as soon as pipeline creation is finished, which is why we'll make them local variables in the create graphics pipeline function instead of class members. Cool, smart. Cleanup should happen at the end of the function by adding these two calls. Welcome to inserted before these lines.
I don't like you like labels, but for me,
Shader stage creation. To actually use the shaders, we'll need to assign them. Can I hear myself? I'm scared. Can I hear myself? Yes, I can hear myself. That's good. Okay. To actually use the shaders, we'll need to assign them to a specific pipeline stage through AK pipeline shader stage created for structures as part of the actual pipeline creation process. Start by filling in the structure for the vertex shader again in the create graphics pipeline.
yes, but
Set it's a vertex shader. We say it's this type. Minimum value
experience with doctor, and I know when
module. We said this is the
because I've been fucked
stage
up.
info module vertex shader, and I guess the name of this main function. Yes.
I
How many bits is there? I guess there's only 2 bits. Oh, there's a lot of bits.
to be honest,
Okay, there's a lot of bits.
to run this real at the end of he came.
Oh god. Anyways, I'm back, people. That's the first thing that's heard after after I started the stream. That's the first thing that's heard. Oh, he came. I didn't came. The guy in a movie came. Next to member specify the shader module containing code and the function to invoke known as entry point. That means that it's possible to combine multiple fragment shaders into a single shader module and use different entry points to differentiate between their behavior. In this case, we'll stick to the standard main behavior. However, oh god. This is one more optional member piece specialization info which you won't be using here, but it's worth discussing. It allows you to specify values for your shader constants. You can use a single shader module where its behavior can be configured at pipeline creation by specifying different values for the constants used in it. This is more efficient than configuring the shader using variables for fuck's sake at runtime. At render time, because the compiler can do optimization like eliminating if statements that depend on these values. If you don't have any constants like that, you can set the member to null pointer, which are struct initialization does automatically. Modifying the structure to suit the fragment shader is easy. Shader. Finish by defining an array that contains these two structs. I'm not gonna commit until we finish this. Oh.
It's a bit.
Okay, let's see. Fixed functions. Render passes conclusion, then we go drawing for fucking thingamajig. Okay. The overall graphics API provided default state for most of the stages of the graphics pipeline. In Vulkan, you have to be explicit about most pipeline states, as it will be baked into an immutable pipeline state object. In this chapter, we will fill in all of the structures to configure these fixed function operations. Holy shit, I don't know how to read. I want it to be somewhere like this. Dynamic state. While most of the pipeline states need to be baked into the pipeline state, a limited amount of them can actually be changed without recreating the pipeline at drawing time. Examples are the size of the viewport, line width, and blend constants. If you want to use dynamic states to keep these properties out, then you'll have to fill in VK pipeline dynamic state create infrastructure like this. This will cause the configuration of these values to be ignored, and you will be able and required to specify the data at drawing time. This results in more flexible setup and is very common for things like viewport and scissor state, which would result in more complex setup when being baked into a pipeline state. Do we need that or not? Let me just get to the C code. C++ code though. Vertex shader info? That's something else, I guess. That's somehow at the end. Dynamic states.
Oh no.
Dynamic state. It's on dynamic state. I don't see that being used anymore though. That's what I'm confused about. Here this states, have the info, and then we don't use it anymore. I'm so confused. I mean, let's copy paste it, and it's and then I guess be done with that. Vertex input. The VK pipeline vertex input state create info structure describes the format of the vertex data that will be passed to the vertex shader. It describes this in roughly two ways: bindings, space between data and whether the data is per vertex or per instance, instancing. Attribute descriptions, type of the attributes passed to the vertex shader, which binding to load from then from and at which offset. Because we are hard coding the vertex data directly into the vertex shader, we'll fill in this structure to specify that there is no vertex data to load for now. We will get back to it in the vertex buffer chapter. Okay. The p-vertex buffer binding descriptions. P-vertex attribute descriptions members point to an array of structs that describe the aforementioned details of loading vertex data. This structure to the grade graphic buffer right after the shader stages.
Silent. And what?
You do indeed do that. And it's very funny. Like a Triceraptor. Like a Triceraptor. Whatever the fuck the fucking... Yeah, T-Rex, perfect. Input assembly. The VK pipeline input assembly states create info. That describes two things: what kind of geometry will be drawn from the vertices and if the primitive restart should be enabled. The form is specifying the topology member that can have values like topology points from vertices, line list, line from every two vertices without reuse, line strip at the end of vertex of every line is used as start vertex for the next line, triangle from every three vertices without reuse, triangle strip the second and third vertex of every triangle are used the first two vertices of the next triangle. Okay. Normally, the vertices are loaded from the vertex buffer by index in sequential order, but with an element buffer, you can specify the indices to use yourself. This allows you to perform optimization like you're using vertices. If you set the primitive restart enable member to VK true, then it's possible to break up lines and triangles in the strip topology mode by using a special index of OFFF or OFFFFFF. We intend to draw triangles throughout this tutorial, so I stick to the following structure.
Oh my god.
Okay. U-ports and scissors. Thank you. No, I'm speaking English, but this was the funniest comment I've ever read. And it's like, I can't understand your language, bro, but I love to help you keep working. Which I don't know if that means my English is very bad or what, but it's very funny.
I think I'm the bothering one.
You're not that
Okay.
Stay there. Yeah, thank you very much. Have you put this? My English isn't that bad, is it?
No, your English is perfect. Can Kitty evaluate? Say something to Kitty.
Hello.
Say hello, I'm Maki.
Hello, I'm Maki. How are you?
Do you see is English perfect? You are asked.
What?
Yes.
How awful is my English? Maybe I was sitting here for it sound like this.
Your English is perfect.
Oh
okay?
God, that killed me.
He says it's a 9 out of 10. What is my English like?
Zero. And none. Oh, that was the funniest and most gut-wrenching comment ever. The viewport basically describes the region of the frame buffer that the output will be rendered to. This will almost always be 0, 0 to it with. Anyways, thank you, Rubish.
Listen here. Listen here, you bastard. Listen here.
Who? Him? He.
You bastard. Don't you ever say something like that about
I will move. I would move away. Anyways, this will almost always be 0, 0 to with height, and in this tutorial that will also be the case. Oh my god! Remember that the size of the swap chain and its images may differ from the width and height of the window. Swap chain images will be used as frame buffers later on, so we should stick to their size. Yeah, swap chain extend. The min depth and max depth values specify the range of depth values to use for the frame buffer. These values must be within 0 to 1 range, but min depth may be higher than max depth. If I'm doing anything special, they should stick to the standard 0 and 1. Viewports define. Okay. While viewports define the transformation from the image to the frame buffer, scissor rectangles define in which region the pixels will actually be stored. Any pixels outside that scissor rectangles will be discarded by the rasterizer. They function like a filter rather than a transformation. The difference is illustrated below.
Love your best friend if you don't love yourself.
Okay, makes sense. Note that the left scissor rectangle is just one of many possibilities that result in that image as long as it's larger than the viewport. So if we want to draw the entire frame, we would specify a rectangle that covers it entirely. That. There. Viewports and scissors. Scissor rectangles can either be specified also. No, this doesn't work. I'm gonna. If it worked, it would be funner, but I don't have that thing. So I just copy paste the links from Twitch because the YouTube bot doesn't work. It's not connecting for some reason. Fuck. I wanna see stream elements, but not connecting YouTube. Yep. But I wanna hear the tutorial. I just wanna see the part. Third-party panel doesn't like support. It makes components of open. I would hope it's fucking public. If it isn't, I'm gonna cry. It is public, so it should work. Settings. Is there really that at the start? If there is, I'm gonna. It looks there is. Really. Does it work? It doesn't like it's working. Doesn't look like it's working. Join, please. It doesn't look like it joined. What? Oh, it still hasn't joined, so that's cool. Oh, it's joined. Okay, perfect. I should just do that. That's cool, that's cool, that's cool. Great. Okay, I fixed that. Fucking asshole. Anyway, viewports and scissor rectangles can either be specified as a static part of the pipeline or as a dynamic state set in the command. While the former is more in line with the other states, it's often convenient to make viewport and scissor state dynamic, as it gives you a lot more flexibility. This is very common, and all implementations can handle this dynamic set without a performance penalty. That's very good actually. When opting for a dynamic viewports and scissor rectangles, you need to enable the respective dynamic state pipeline. Isn't that this thing? Scissor create info, dynamic viewing 32T, dynamic size, dynamic state size. And then you only need to specify the count and pipeline creation time. So I need to set up the entire state. Does this? Do we have this here? It's so confusing. I should have a viewport and thing here. Am I? This is so confusing, brother. Let's see. Because they say one thing, vertex input info. Here, input assembly, we have, but we don't use. We have this.
Oh god.
Yes, we do. So it's input assembly, then this. We don't need this at all. Because I guess we're gonna be doing that dynamically. Viewports and scissor rectangles select step. For the scissor setup. Input set. Okay, and this, do we have this? Set 1
Oh my god.
Yes, we don't have to. Independent of how you set it, it's possible to use multiple viewports and scissors. That's enabling GPU features, so logical device creation. So we're just gonna be doing this and this. I guess if we don't use any of this in this part, or maybe next part, I'm so confused. Okay, rasterizer. The rasterizer takes the geometry that is shaped by the vertices from the vertex shader and turns it into fragments to be colored by the fragment shader. It also performs depth test, phase calling, and the scissor test, and it can be configured to output fragments that fill entire polygons or just the edges via frame rendering. All this is configured using the VK pipeline rasterizer creation state creator. That's next.
Oh god.
We put that here.
Oh god.
The depth clamp enable is set to VK true, then fragments that are beyond the near and far planes are clamped to them as opposed to discarded. This is useful in some special cases like shadow map. Using this requires enabling a GPU feature. Is there anything that doesn't require enabling a GPU feature? What's this something more? Cool. It does work. Okay, I was scared for a second. Anyways, let's see. Spell near and far flames. Okay, yes. Rasterizer discard enabled. It's also here, yes. If it's set to true, then geometry never passes through the rasterizer stage. This is basically disabling output to the frame buffer. Why would we have that? Polygon mode. Polygon mode fill. Determines how the fragments are passed. For geometry, the following modes are available. Fill the area of polygon with fragments. Edges are drawn as lines, vertices are drawn as points. Cool. Using any mode other than fill requires enabling a GPU feature. Is there something that doesn't need a GPU feature? Rasterizers line width. Line width member is straightforward. It describes the thickness of line in terms of number of fragments. The maximum line width that is supported depends on the hardware, and any line thicker than 1.0 requires you to enable the wide lines GPU feature. Call mode. The call mode variable determines the type of face calling to use. You can disable calling, call the front face, call the back faces, or both. Oh, that's cool. Oh my god. I'm glad it's not my English at least. Though I was laughing because I thought it wasn't true. But this is C++.
Oh no.
Congratulations on being a polyglot, though. I'm a polyglot in programming languages. Though I do know 2 semi-3 languages. I know my mother tongue, the Negri. I know English, and I know a bit of Italian. And by a bit, I know how to read and say stuff. I just don't know how to. Not that. It's one of these. Okay, it's not that one. It's this. I know a bit of Italian, and by that I mean I know how to speak it, but I don't know much else.
What do
I
you
can't understand.
think?
Yeah. So he said.
Fuck.
He said that he meant the programming language.
Ah, fuck. Okay. I'm sorry. I'm ready to beat you. I'm sorry.
I was like, fuck. I'm sorry, but that was funny. That was still funny because I was like, oh my god.
Chat about languages. And I was like, is he fucking talking shit about your English again? Let me fucking at him. Programming languages, I'm very sorry. You can see, I have no leash on me.
A rabbit dog. Call the back faces or both. The front face variable specifies the vertex order for faces to be considered front facing and can be clockwise or counterclockwise. Cool. Okay, we go this. The rasterizer can alter the depth values by adding a constant value or biasing them based on a fragment's slope. This is something used for shadow mapping, but we won't be using it. Just set the depth bias enable to wiki pose. That's cool. I wonder. Okay, I have this thing here. I'm just gonna try. I have this fancy tool. Doesn't reveal anything, you know. Power toys. I don't know if you use it. I don't know if you're using. If anyone uses it. I think people use it. It's cool. I wanna try. There is not screen roller, fancy zones. I wanna do that. Yep. What I want to do is create a custom one. Chat plus string. Okay, I'm gonna screenshot this because I can't remember that. Quick string. Okay. Oh my fucking god! I'm so. What? Okay. What the fuck? Okay, this stays popped. Okay. Delete. Remove. Merge them. Okay. Okay. So what I'm gonna do is do like 1/3. Cancel. Okay. Let's try again. Let's merge these two. 496. Save. Let's choose. Okay. Let's on number 3. Let's use this. Okay. And then I can use. And how do we use this? Activation shortcut. Windows Shift tilde. Okay, no, I don't want the layout editor, I want to figure out how to use it. Okay, that way. That way. That way, perfect. Okay, now I can see the chat better. Okay, I'm gonna edit it still. Because I hate how fucking... Zero pixels, yes, thank you. Let's have it, save, thank you.
Oh.
Okay, then let's do this. Okay, even better. I mean, that's not really pixel perfect, but I can't really fault it. Cool. I can even probably hack it. How much is usually the Twitch chat size? I can see it just about. Pop out chat. Well, let me see. Okay, yes, that's what I want. For 3, edit.
You don't think so? I'm sure I got scared.
Okay, now. Okay, better. Much better. Okay, I like this. Okay, so what I did is, let me show you. There's this thing, and then I can launch this layout editor. You can see it, okay, that's good. So I can use this, and then I edited this one to be like, hey, I'm gonna use it this way. And then I put my Twitch chat, my YouTube chat, and the rest of the screen here, which is very cool. Yes, thank you. Which I feel is kind of cool. Anyways, Rupesh, if you're still here, what you doing? Do you program a lot? I don't think you're here anymore. That's sad. Anyways, let's see. VK false. You cannot adapt. This is sometimes used for shadow mapping, but we want to use it set the bias enable to false. And these are optional. Do we use the optional ones? No.
That man.
No optional stuff.
Out to run, bro.
Let's see. Multi-sampling. Have so many chats here. Anyways, multi-sampling. The VK pipeline multi-sample state creating for struct configures multi-sampling. Top chat, please tell me there's more. Oh, thank fuck there isn't. I was scared for a second. Okay. Struct configures multi-sampling, which is one of the ways to perform anti-aliasing. It's worked by combining the fragment shader results of multiple polygons that rasterize to the same pixel. This mainly occurs along edges, which is also where the most noticeable aliasing artifacts occur. Because it doesn't need to run the fragment shader multiple times if only one polygon maps to a pixel. It's significantly less expensive than simply rendering to a higher resolution and then downscaling. Enabling it requires enabling a GPU feature. Oh my god. Is there something that doesn't require a GPU feature, for hell's sake? Everything I do is a GPU feature, it seems. I will revisit multi-sampling in a later chapter. Oh, that's cool. Depth and stencil testing. Yes. If you're using a depth and or stencil buffer, then you also need to configure the depth and stencil test using VK pipeline depth and stencil state create info. Structs. We don't have one right now, so we can simply pass a null pointer instead of a pointer to such a struct. We'll get back to it during the depth buffering chapter. Color blend. After a fragment shader has returned a color, it needs to be combined with the color that is already in the frame buffer. This transformation is known as color blending, and there are two ways to do it. Mix the old and new value to produce the final color. Combine the old and new value using a bitwise operation. Those are not very good strategies, I feel like. Anyways, and there are two types of structs to configure color blend. The first struct, VK pipeline color blending attachment state, contains the configuration per attached frame buffer, and the second struct, VK pipeline color blend state create info, contains the global color blending options settings. In our case, we only have one frame buffer. So let's just get this right here. This per frame buffer struct allows you to configure the first way of color operation that will be performed at best demonstrated using the following pseudocode. If blend is enabled, get the RGB and the source blend factor times the new color with some operations, and destination color blend factor with the old color, and then same with the alpha factor. And if it's not enabled, we just set final color to new color, and then we do final color and color white mask. White mask, not white mask. I can't read, for fuck's sake. If blend enable is set to VK false, then the new color from the fragment shader is passed through unmodified. Otherwise, the two mixing operations are performed to compute a new color. The resulting color is AND with the color white mask to determine which channels are actually passed through. The most common way to use the color blending is to commit alpha blending, where we want the new color to be blended with the old color based on its opacity. The final color will then be computed as follows. This can be accomplished setting the following parameters. Let's see. Blend enable, so enable it. Source blend factor blend source alpha 1 minus source alpha. Operation is add. Blend factor 1. And then blend factor 0.
Okay.
And alpha blend operation.
I have lots of story to share with you, don't worry. And
you can find all the possible operations in the VK blend factor and VK blend op enumeration in the specification. Second structure references the array of structures for all the plane buffers and allows you to set blend constants that you can use as blend factors in affirmative.
And everything is gonna be fine. Just so that you know, okay? I didn't know.
The second structure references the array of structures for all the frame buffers and allows you to set blend constants that you can use as blend factors in the aforementioned calculation.
You know, it doesn't know that the danger is over, you know? You just have to send it home to the family. Yes, that's the thing. Yeah.
Now this isn't optional. Sometimes optional is optional, sometimes optional is not optional. As always. If you want to use the second method of blending, bitwise combination, then you should set logic OP enable to VK true. This bitwise operation can then be specified in the logic OP field. Note that this will automatically disable the first method as if you had set blend enable to VK false for every attached frame. The color white mask will also be used in this mode to determine which channels in the frame buffer will actually be affected. It's also possible to disable both modes as we've done here, in which case the fragment color will be written to frame buffer. Okay. What?
Oh shit!
Really? We actually... Oh, fuck. It shows us something and doesn't tell us what we should write. Everywhere. So I'm like, what the fuck am I writing actually? RGBA. Oh shit, oh shit. I don't see S type here. Is that wrong or usual? If it's wrong. I can't really check right now. If you want to set blah blah. Pipeline layout. We can use uniform values in shaders, which are global similar to dynamic state variables that can be changed at drawing time to alter the behavior of your shaders without having to recreate them. They are commonly used to pass the transformation matrix to the vertex shader, or to create texture samplers in the fragment shader. These uniform values need to be specified during pipeline creation by creating a VK pipeline layout object. Even though we won't be using them until a further chapter, we are still required to create an empty pipeline layout. Sad, but cool. Create a class member to call this object because we'll refer to it in other functions at a later point.
Oh my god, the second person.
Here go dynamic states. Okay, I feel like this is cool. No?
Because he got so lucky.
So that makes sense. The structure define specifies push constant, which are another way of passing dynamic values to shader that we may get into a future chapter. The pipeline layout will be referenced to the program's lifetime, so it's destroyed at the end.
Oh no.
Let me just scale it back a bit so I can see. So it's pipeline shader, stage vertex, shader modules, shader module fragment. You have the shaders, then you have pipeline create shader info. Don't need these two. Input assembly, false structure rasterize, false, fill 1F back blah blah multi-sampling, VK false color attachment, false 0 dynamic states, pipeline create layout. Okay, cool. That seems correct.
Did she reply? Or did you
Let's get a working version and then yes, I think I already said that multiple times, so and class is concluded. Okay, settled. Before we can finish creating the pipeline, we need to tell Vulkan about the frame buffer attachments that will be used while rendering. We need to specify how many color and depth buffers there will be, and how many samples to use for each of them, and how their content should be handled throughout the rendering operations. All of this information is wrapped in a render pass object for which we'll create a new create render pass function. Call this function from it Vulkan before create them. Is there any time finish everything in order? F6. And by F in fact sake, not anything else that could be.
Wow.
Let's see. Attachment descriptions. In our case, we'll just have a single color buffer attachment represented by one of the images in the swap train. The format of the color attachment should match the format of the swap chain images, and we are not doing anything with multi-sampling yet, so we stick to one sample. Load operation, OP clear, and store operation is OP store. The load OP and store OP determine what to do with the data in the attachment before rendering and after rendering. We have the following choices for load OP: load, clear, and unclear. Reserve the existing content for the attachment. Clear the values to a constant at the start. Existing. Why does it feel like something changed? It didn't. Okay. Existing content are undefined, we don't care about them. Cool. Let's see. In our case, we're going to use the clear option to clear the frame buffer to black before drawing a new frame. There are only two possibilities for the store OP. OP store and don't care. Rendered contents will be stored in memory and can be read later. Contents of the frame buffer will be undefined after the reading operation. We're interested in seeing the render triangle on screen, so we're going with the store operation here. Cool. And the and store OP apply to color and depth data, and stencil load OP, stencil store OP applies to stencil data. Hope application won't do anything with the stencil buffer, so the results of loading and storing are irrelevant. Make image layout and define we preserve source cooker. Textures and frame buffers in Vulkan are represented by VK image. Objects with a certain pixel format, however, the layout of the pixels in memory can change based on what we're trying to do with an image. Some of the common layouts are color attachment optimal. Images used as color attachments. Layout present source KHR, which is what we use. Images to be presented in the swap chain, and then transfer destination optimal. Images to be used as destination for memory copy operations. We'll discuss this topic in more depth in the texturing chapter, but what's important to know right now is that images need to be transitioned to specific layouts that are suitable for the operations that are going to be involved next. The initial layout specifies which layout the image will have blah blah blah. The initial layout specifies which layout the image will have before the render pass begins. The final layout specifies the layout to automatically transition to whatever the render pass finishes. Using weak image layout undefined for initial layout, it means that we don't care. What previous layout the image was in. The caveat of this special value is that the contents of the image are not guaranteed to be preserved, but that doesn't matter since we are going to clear it anyways. We want the image to be ready for presentation using the swap chain after rendering, which is why I use VK image layout present source KHR as final layer. Fuck.
Oh my god.
Subpasses and attachment references. Single render pass can consist of multiple subpasses. Subpasses are subsequent rendering operations that depend on the contents of frame buffers in previous passes. For example, a sequence of post-processing effects that are applied one after another. If we group these rendering operations into one render pass, then Vulkan is able to reorder the operations and conserve memory bandwidth for possibly better performance. For our first triangle, however, we'll stick to a single subpass. If you group these rendering operations into a render pass, don't know what that means really, but cool. I keep reading this like I'm gonna understand it, and that's awful. I wonder if I would have more luck just copy pasting, for example, the tutorial here from like texture mapping, and then just try my best to, go back. And if I need something, ask. If I don't need anything, be done with it. That would be a fun thing. Anyways, let's see. Every subpass references one or more of the attachments that we described using the structure in the previous section. Yes. The references are themselves PK attachment reference structs that look like this. Again, a struct of a struct of a struct of a struct. It's structs all the way down. The attachment parameter specifies which attachment to reference by its index in the attachment description array. Our array consists of a single wiki attachment description, so its index is 0. The layout specifies which layout you would like the attachment to have during a subpass that uses this reference. Vulkan will automatically translate the attachment to this layout when the subpass is started. We intend to use the attachment to function as a color marker, and the wiki image layout color attachment optimal layout will give us the best performance as the name implies.
Against it. The slogan say against
The subpass is described using the performance as the name implies.
Weird body
My fucking god, where did blah blah. The subpass is described using a wiki subpass descriptions. Subpass description structure, yes. Vulkan may also support compute subpasses in the future, so we have to be explicit about this being a graphics subpass. Next, we specify the reference of the color attachment. The index of the attachment in this array is directly referenced from the fragment shader with the layout location 0 out color directly. Finally, something connecting something somehow, somewhere, maybe, you know. The following other types of attachments can be referenced by a subpass: P input attachments that are read from a shader; P resolve attachments used for multi-sampling color attachments; P depth stencil attachments for depth and stencil data; P preserve attachments that are not used by this subpass but for which the data must be preserved. Okay, let's see next. Let's just random pass. Now that the attachments and the basic subpass referencing it have been described, we can create a render pass itself. Create a new class member variable to hold on
Jenny!
wiki render pass object right above the wiki pipeline layout variable.
Oh my god, how romantic!
It's just so fucking boring. The render pass object can then be created by filling in the wiki render pass create input structure with an array of attachments and subpasses. The wiki attachment reference object references attachments using an indices of this array. My brain is broken actually. I just want to see a triangle on the screen, and then I wouldn't be so broken. I hope truly. But we'll see, I guess, we'll see. Cool. Let's see. With an array of attachment and subclasses, the wiki attachment reference object reference attachments using the indices of this array. Okay, kinda makes sense for attachment. Just like the pipeline layout, the render path will be referenced to the program, so it will be cleaned up at the end. Finally, in the next chapter, we might see nothing, probably. Because we're here, conclusion. This is the graphics pipeline, then we have the drawing tricks. So, a lot of stuff. See? Holy shit. Anyways.
Oh my god. Same.
Pass.
Same.
We can now combine all the structures and objects from the previous chapters to create a graphics pipeline. Here's the type of objects we have now. As a quick recap, please, I need a recap. Please, God, please. Shader stages, the shader modules that define the functionality of the programmable stages of graphics pipeline. Fixed function state, all of the structures that define the mixed function stages of the pipeline, like input assembly, rasterizer, viewport, color blending, the pipeline layout, the uniform and push values referenced by the shader that can be updated at draw time, render pass. The attachments referenced by the pipeline stages and their usage. Still don't know what that means. I feel like I'm reading this and I'm not remembering anything, and I will only remember when I reread it again when I need it. But this might give me some good pre-knowledge. Let's put it that way.
They view the world differently. They are still there.
Fucking good. I need to drink some water. Can we fill water?
Yes. So, Kitty, I'm sorry. Just 3 seconds. I'll be.
I have to. My mouth is so dry from speaking. I have not cut up for a long time. أنا ما كنت أبي أفهم الصوت.
No, yes, I just drank drink.
Don't worry. I'm not gonna kill you with water. Surprising, I don't think it's possible. I'll with this up to. I think. What is this? 3 and something liters. Yeah, I think I can actually drink that. Hello, cat. Cat.
Cat, and a dance, and a dance.
Cat. I'm a kitty cat. And a dance, and dance. Okay, let's continue. Just water.
For the kitty. For the kitty.
Okay.
Hope the kitty understood that.
After drinking, I need a small amount of time to remember how to speak correctly. Okay. Anyways, all of this combined fully define the functionality of the graphics pipeline. So we can now begin filling in the VK graphics pipeline create infrastructure at the end of the create graphics pipeline function. But before the call to VK destroy shader module. So here. Oh my fucking god. Cat. I'm gonna kill you. She clicked something or heard something, get out. Can I hear myself? Okay, I can hear myself. I sound awful. What the fuck? Do I sound awful? I don't. Okay, I just sound weird, but that's kind of the normal weird. Let's see. The VK graphics pipeline create info. Here. Okay, here we can put it. Okay. Structure pipeline create info. Stage. I know pipeline layout. We don't need. This says 2 stages we have. We start by referencing it, yes. We don't do all of this. I guess we don't. We don't need that. Shut up, fucking cat. Vertex input assembly, viewport state, rasterizer, multi-sample color branding, dynamic state. Cool. Then pipeline layout. Yep, that's what I thought. Let's just put all of that together. Then we have the render passes. And finally, we have the reference. Can you please feed them? Or something. I don't know what they want. They probably want you to feed them. No, you know what? Fuck it. I'm gonna be back right away.
Okay. Nothing, I was confused.
Fucking good with the kids. Okay, I'm back. And the cats still have the same amount of food. I'm just back. For what happens.
Huh? What?
I'm just there. Oh, They came back with me. What the fuck? Oh fuck, I feel so that. What the fuck is happened? I don't know.
Oh my.
And finally we have the reference to the user pass and the index of the subpass where this graphics pipeline will be used. Oof. Oof, brother, why do I feel bad? The requirements, okay. Also possible to use other render passwords with this pipeline instead of this specific instance, but they have to be compatible with render pass. The requirements for the compatibility are described here. We won't be using that feature in this tutorial. My uši to čepsili. How? No, don't worry. Proći ću. Ne treba, ne mogu stati. There are actually two more parameters, base pipeline handle, base pipeline index. Vulkan allows you to create a new graphics pipeline by deriving from an existing pipeline. The idea of pipeline derivatives is that it is less expensive to set up pipelines when they have much functionality in common with an existing pipeline, and switching between pipelines from the same parent can also be done quicker. Makes sense. You can either specify the handle of an existing pipeline with base pipeline handle, or reference another pipeline that is about to be created by the index with base pipeline in school. Other index. Right now, this is there is only one single pipeline, so we'll simply specify a null handle and an void index. These values are only used if the VK pipeline create derived bit plug is also specified in the flags of field of the VK graphics pipeline create info. Now prepare for the final step by creating a class member to hold the VK pipeline object. Yeah, VK pipeline. And finally create the graphics pipeline. Fuck yeah. VK graphics pipeline function actually has more parameters than the usual object creation function in Vulkan. It is designed to take multiple VK graphics pipeline create info objects and create multiple VK pipeline objects in a single folder. Second parameter, for which we pass the VK null handle argument, references an optional VK pipeline cache object. The pipeline cache can be used to store and reuse data relevant to the pipeline creation across multiple calls. The VK create graphics pipeline. And even access programs program execution if the cache is stored to a file. Cool. Even access program execution is cache cool. This makes it possible to significantly speed up pipeline creation at a later time. We'll get into this in the pipeline cache chapter. The graphics pipeline is required to load command drawing operation, which will only be destroyed at the end of the program. Our program to confirm everything works. Please, everything. Please.
Oh god.
It looks like it's working to me. I click exit. Yes. That thankfully worked. Create a graphics pipeline. So, okay. New window. And get going here. Create the graphics pipeline. Created. It's pipeline. Added shaders. Create a graphics pipeline. Okay. Graphics pipeline. He's gonna die. Push. Okay, I'll get to that. Let's see. Okay, how many chapters? 1, 2, 3, 4. So around 5 more chapters, and we can finally have a fucking triangle done. Not multiple stuff, not a cool cube or something, a triangle. A single triangle. Let's not forget a single triangle, and then we have 4 more chapters to introduce vertex buffer, and 2 for uniform buffers, and then 3 for fucking textures, depth buffers, loading model, generating meat buffers, computing, so much stuff in so many chapters for such little things.
That's perfect.
That would be funny. Okay. That's why I didn't say it's the same fucking code. Frame buffers. Okay. Let's see. Cat, please. Frame buffers. We have talked a lot about frame buffers in the past few chapters, and we've set up the render path to expect a single frame buffer with the same format as swap chain images, but we haven't actually created any. True, Sag. Just look at Discord. You to or YT, I think. YT? Cool. I think I see a viewer, so it was okay. Let's put them all in. But we haven't actually created any. The attachments specified during the render path creation are bound by wrapping them into a VK frame buffer object. A frame buffer object references all of the VK image view objects that represent the attachment. In our case, that will be only a single one. Okay, I really don't know to read, see, or anything in between. The color attachment. However, the images that we have to use for the attachment depends on which image the swap chain returns when we retrieve one for presentation. That means that we have.
Oh fuck!
That means that we have to create a frame buffer for all of the images in the swap chain and use the one that corresponds to the retrieved image at drawing time. To that end, create another std vector class member to call the frames. So much copy pasting. I haven't written a lot of this because I feel like A, it's boring stuff, and B, no one is gonna remember. I'm not gonna remember all of these options. The next time I'm gonna be needing any of this, I'm gonna be going back here and just skip reading and copy paste the code I need. We'll create an object for this array in a new function called create frame buffers. So void function. Okay, let's see. Start by resizing the containers to flow the modules. Then we iterate through them.
Wait, did she kill?
You get the attachment. This swap chain image views at I. So there's only one attachment per frame buffer, I guess. Oh, what the fuck happened here? Well, nothing. Here everything seems fine to me too.
True.
I don't know. Seems fine to me.
He gave her a black eye.
Ah, I have comments now. Rupesh Verma commented. I'm glad. Thank you. Anyways. I'm so sad for that. Anyways, yep. We set the render path, the attachment count, the attachments, which is just one. Cool, I think. I'm not sure. Okay, as you can see, creation of frame buffers is quite straightforward. We first need to specify with which render pass the frame buffer needs to be compatible with. You can only use a frame buffer with a render pass that it's compatible with, which roughly means that they use the same number and type of attachments. The attachment count and p attachment parameters specify the wiki image objects that should be bound to respective attachment descriptions in the render pass at p attachment array. Don't know what that is. The width and height parameters are self-explanatory. Layers refer to the number of layers in the image arrays. Our swap chain images are single images, so the number of layers is 1. We should delete the frame buffers before the image is used in render pass after we finish rendering, like everything else. Let's get the triangle up and running and then we can commit. Or do I commit now? No, let's commit now. Better safe than sorry. Yeah, frame buff.
Oh my god. This is such a marvelous movie.
Wood.
Oh, God bless.
God bless them.
Oh.
Okay. Commands in Vulkan, like drawing operation and memory transfers, are not executed directly using function calls. You have to record all of the operations you want to perform in a command buffer object. The advantage of this is that when we are ready to tell Vulkan what we need to do, all of the commands are submitted together. Vulkan can more efficiently process the commands since all of them are available together. In addition, this allows command recording to happen in multiple threads if so desired. Command loops. Let's add this right away. We have to create a command pool before we can create command buffers. Command pools manage the memory that is used to store the buffers, and command buffers are allocated from them. Add a new class member. Create this command.
Yeah.
Command pool creation only takes 2 parameters. There are 2 possible flags for command pools. VK command pool create transient bit, hint that command buffers are re-recorded with new commands very often, may change memory allocation behavior. VK command pool create reset command buffer bit, allow command buffers to be re-recorded individually. Without this flag, they all have to be reset together. Pool create info, use reset, okay. And then reset the queue family indexes. Cool. We will be recording a command buffer every frame, so we want to be able to reset and record over it. Thus, we need to set the VK command pool flag bit for our command pool. Second one, okay. Command buffers are executed by submitting them on one of the device queues, like the graphics and presentation queues we retrieved. Each command pool can only allocate command buffers that are submitted on a single type of queue. We are going to record commands for drawing, which is why we chosen graphics queue family.
He's gonna get you.
So graphics queue and present. Okay. Finally, let's destroy it. Okay. Eject. Lab 1. Fucking line. Command buffer allocation. We can now start allocating command. Create PK command buffer object as a class member. Cool.
Oh my god.
start adding more and more stuff. Void and here we add this. Command buffers are allocated with fuck off. Okay, command buffers are allocated with the vkallocate command buffer function, which takes a vk command buffer allocate info struct as a parameter that specifies the command pool and number of buffers to allocate. So we say we only want to allocate one buffer primary to this command pool that we have. The level parameters specify if the allocated command buffer are primary or secondary command buffer. Primary or secondary. So primary can be submitted to a queue for execution, but cannot be called from other command buffers. And secondary cannot be submitted directly, but can be called from primary command buffers. We won't make use of the secondary command buffer functionality here, but you can imagine that it's helpful to reuse common operations from the primary command buffers. Since we are only allocating one command buffer, the command buffer count parameter is just one. Cool. We will now start working on the record command buffer function that writes the commands we want to execute into a command buffer. The vk command buffer used will be passed as a parameter, as well as the index of the current swap chain image we want to write to.
Oh my god.
Cool.
Is the lieutenant?
We always begin recording command buffer by calling begin command buffer with a small vk command buffer begin info structure as an argument that specifies some details about the usage of this specific command buffer. Cool. So we do this. So command buffer begin info. We set there is no flags, we don't inherit from anything, and that this is the type. The flags parameter specifies how we're going to use the command buffer. The following values are available. We choose runtime submit bit. The command buffer will be recorded right after executing it once. Re-recorded right after. The command buffer usage render pass continue bit. This is a secondary command buffer that will be entirely within a single render pass. The command buffer can be resubmitted while it's also already pending execution. None of these flags are applicable for us, right? The p-inherent and self parameter is only relevant for secondary command buffers. It specifies which state to inherit from the calling primary command buffer. If the command buffer was already recorded once, then a call to vk begin command buffer will implicitly reset.
Oh no.
It's not possible to append commands to a buffer at a later time. Cool. Maybe. Starting a render pass. Oh my god. Drawing starts by beginning the render pass vk begin render pass. The render pass is configured using some parameters in. I just wanna go into the C++ code because I don't know it.
God.
Where is this? Okay, reward. Because I was just confused. Nothing. I'm always confused.
Oh no. Oh no. Oh no. Oh no.
Let me just do these updates. Let's see if this works. Installing. Okay. The first parameter are the render pass itself and the attachments to bind. We create a frame buffer for each swap chain image where it is specified as a color attachment. Thus, we need to bind the frame buffer for the swap chain image we want to draw. Using the image index parameter which was passed in, we can pick the right frame buffer for the current swap chain image. What the fuck this mean? Thank you, I guess. Extend. The next two parameters define the size of the render area. Okay, this thing. The render area defines where shader loads and stores will take place. Pixel per size this range will have undefined values. It should be match size of the attachments for the best performance.
Yes.
Understood. A clear value. Clear color is gonna be black, I think. The last two parameters define the clear values to use for wiki attach load op clear, which used as load operation for the colors. I define the clear color to simply be back with 100% opacity. Understood. Right, here. Begin render pass. How many percent does this have? Cool. The render pass can now begin. The render pass can now. Why is there? I hate this. I hate the minimal pixel between the fucking things. This and this. That's cool. The render pass can now begin. All the functions that record commands can be recognized by their VKCMD prefix. We all return void, so there will be no error handling until we finish recording. The first parameter for every command is always the command buffer to record the command to. The second parameter specifies the details of the render pass we've just provided. The final parameter controls how the drawing commands within the render pass will be provided. It can have two values. Subpass content inline, the render pass commands will be embedded in the primary command buffer itself and no secondary command buffer will be executed. Subpass contents secondary command buffer, the render pass commands will be executed from secondary command buffers. We will not use the secondary command buffer, so we'll go with the first option. Cool. You can now bind the graphics pipeline. Cool. The second part specifies if the pipeline object is a graphics or compute pipeline. We've now told Vulkan which operations to execute in the graphics pipeline, which attachments to use in the fragment shader. As noted in the fixed functions chapter, we did specify a viewport please come on. We did specify viewport and scissor state for this pipeline to be dynamic. We need to set them up into command buffer before issuing our draw commands. Oof. We're now ready to issue draw commands. Matrich! No! Oh fuck.
Oh god.
The actual wiki command draw function is a bit anticlimactic. Very true. But it's so simple because of all the information we specified in advance. It has the following parameters aside from the command buffer. Vertex count, even though we don't have a vertex buffer, we still have 3 vertices to draw, which is true. Instance count, used for instance rendering, use 1 if you're not doing that, we are not. First vertex, the first offset into the vertex buffer defines the lowest value of geovertex which is in our case, of course, 0. In first instance, user of, for instance, rendering defines the lowest value of GL instance syntax, again 0. Finishing up, the render pass can now be entered. If you finish the recording commands, it says failed. Probably not, I hope. See, we shall see. Insert command pool and let's see, create a command pool and created command pool with function command buffer push. Next, mały tab, znaczyć rendering and presentation, and then frames in light and swap chain creation. Cool. This is the chapter where everything is going to come together. We are going to write the draw frame function. This will be called from the main loop. Fuck off. I have stood up like set. Look at this shit. How many times can I stood to eat?
Maybe she's anxious. Don't yell at her. Pet her. Kiss her. Please.
See that she doesn't want to be.
Maybe she's kitty.
I can't sit at her for her to eat because look, I'm gonna come here, she's gonna come to eat.
What? Here. They don't want to eat unless someone walks them to their food. I think they're just anxious kitties. Because there's a thing like that with cats where they want you to watch them as they eat because they feel scared. And you know, we had a lot of situations at the last apartment where our neighbors were very mean and would bang at our doors and our walls, and our kitties would get very scared of them. We also would shake literally in fear because we never knew who the person or who were that were doing it. And we got kicked out of that apartment because of those people. They were bad-mouthing us while we were the ones receiving the shit. And it was a nice apartment, I liked it, and I was very good with the owner. And I was punctual and had records of every bill and everything, and took care of the apartment. Did clean it so well, I didn't really spec on it. They accused us of things that they were doing. They would play very loud music at 7 a.m. and we couldn't sleep. When it was my birthday and I was being happy, when Maki got me a gift, they banged on the walls, and then we couldn't celebrate my birthday. And on Maki's birthday, we received the notice, basically, that we have X amount of days to get out. What did you say, Maki?
Did they really back on your birthday? To remember. Was it on your birthday? Like it or Christmas?
That was not Christmas.
I think it was because I don't think.
It's not Christmas, I don't know.
Because from what I remember, the first time they hit the wall.
We didn't hit the wall.
No, not we. They. When they hit the wall. Yeah, when they hit the wall, it was like literally New Year. I think.
No, everyone's being loud then.
No, but people hit the wall. I think on New Year or something.
Really? Oh no.
I think so.
I don't think hit it so often. In the winter especially. And sometimes
I'm so confused. Oh, me too.
said that to the owner of the apartment.
Crazy fuck. Girlfriend.
And I told him that I don't feel safe.
That's stupid. Girlfriend.
That
Outline of a frame.
free.
At a high level, rendering a frame in Vulkan consists of common sets of steps. Wait for the previous frame to finish, acquire an image from the soft chain, record a command buffer which draws the scene onto the image, submit the recorded command buffer, present the swap chain image. While we will expand the drawing functions in the later chapter, for now this is the core of our rendering. Cool. How does that work here? I don't understand.
And I tried to the owner and said,
Just synchronization. A core design philosophy in Vulkan is the synchronization of execution on the GPU is explicit. The order of operation is up to us to define using various synchronization primitives which will tell the driver the order we want things to run in. This means that many Vulkan API calls which start executing work on the GPU are asynchronous. The function will be returned before the operation has finished. In the chapters there are numbers of events. In this chapter there are a number of events that we need to order explicitly because they happen on the GPU, such as acquire an image from the swap chain, execute commands that draw onto the acquired image, present the image to the screen for presentation, returning it to the swap chain. Each of these events is set in motion using a single function call, but they are all executed asynchronously. Function calls will return before the operations are actually finished, and the order of execution is also undefined. This is a functional because each of the operations depends on the previous one finishing. Thus, we need to explore which primitives we can use to achieve the desired ordering.
Psychiatry?
A semaphore. Semaphores. A semaphore is used to add order between queue operations. Queue operations refer to work we submit to a queue, either in a command buffer or from within a function, as we'll see later. Examples of queues are the graphics queue and the presentation queue. Semaphores are both used both to order work inside the same queue and between different queues. This happens to be two kinds of elements of binary and timeline. Don't worry.
Yes. Please don't.
Can I be cut? Yes.
Ever to happen to me to be separated from my kids.
There happens to be two kinds of semaphores in the Vulkan, binary and timeline. He has only binaries. Why hell no? He can swim. At least he can float, probably.
Oh, true. I'm dumb.
Why did you think he's gonna drown? Can you not hear me?
Huh?
Can you hear me when I talk to you?
Sometimes.
You should lower the volume there.
Okay.
Because I keep speaking to you and you ignore me, I think you're ignoring me.
No, I don't hear you.
Okay, well, you should lower the tone like you did. Because I just told you, well, he has fucking arms, what is the matter? He can float, and you're like,
Sorry, I don't hear you.
doesn't matter. Because only binary semaphores will be used in this tutorial, will not discuss timeless semaphores. Further measure of the semaphore exclusively refers to binary semaphores. A semaphore is either unsignal or signaled. It begins life as unsignaled. The way we use a semaphore to order queue operations by providing the same semaphore as a signal semaphore in one queue operation and as a wait semaphore in another queue operation. For example, let's say we have semaphore S and a queue operation AB that we want to execute in order. What we tell Vulkan is the operation A will signal semaphore S when it finishes executing, and operation B will wait on semaphore S before it begins executing. Cool. When operation A finishes, semaphore S will be signaled, while operation B won't start unless S is signaled. After operation B begins executing, semaphore S is automatically reset back to being unsignaled, allowing it to be used again. To the code of what was just described. Yeah. Note that in this code snippet, both calls to VKQ submit return immediately. The wait only happens on the GPU. CPU continues running without blocking. To make the CPU wait, we need a different synchronization primitive, which we'll now describe. Fence. Cool. A fence has a similar purpose in that it is used to synchronize execution, but it is for ordering the execution of the CPU, otherwise known as the host. Simply put, if the host needs to know when the GPU has finished something, we use a fence. Similar to semaphores, fences are either in signal or unsignal state. Whenever we submit work to execute, we can attach a fence to that work. When the work is finished, the fence will be signaled. Then we can make the host wait for the fence to be signaled, guaranteeing that the work has finished before host continues. A current example is taking screenshot. Say we have already done the necessary work on the GPU. We need to transfer the image from the GPU over to the host and then save memory to the file. We have command buffer A, check executes the transfer, and fence F. We submit command buffer A with fence F, then immediately tell host to wait for the signal. This causes the host to block until the command buffer A finishes execution, as we are safe to let host save the file to disk as memory transfer has completed. Work A, fence F, wait for fence, save screenshot to disk. Unlike the semaphore example, the example does block host execution. This means host won't do anything except wait until execution has finished. For this case, we had to make sure that the transfer was complete before we could save the screenshot to disk. In general, it is preferable to not block the host unless necessary. We want to feed GPU and the host with useful work to do. Waiting on fence to signal is not useful work, thus we prefer semaphores or other synchronization primitives not yet covered to synchronize our work. Fences must be reset manually to put them back into unsignal state. This is because fences are used to control execution of the host, and so the host gets to decide when to reset the fence. Contrast this to semaphores which are used to order GPU work on the GPU without the host being involved. In summary, semaphores are used to specify the execution order of operations on the GPU, while fences are used to keep the CPU and GPU in sync with each other. Which do we choose? I guess what do we choose? I'm sorry. We have two synchronization primitives to use, and conveniently two places to apply synchronization. This is to apply synchronization. Swap chain operations and waiting for the previous frame to finish. We want to use semaphores for swap chain operations because they happen on the GPU, thus we don't want to make the host wait around if we can help it. For waiting on the previous frame to finish, we want to use fences for the opposite reason, because we need the host to wait. This is so we don't draw more than one frame at a time. Because we re-record the command buffer every frame, we cannot record the next frame's work to command buffer until the current frame has finished executing, as we don't want to override the current contents of the command buffer while the GPU is using it. Creating the synchronization object. We'll need one semaphore to signal that an image has been acquired from the swap chain and is ready for rendering, and another signal rendering has finished and presentation can happen, and a fence to make sure only one frame is rendering at a time. Create 3 class members to store semaphore objects and fence objects. To create semaphores, follow the last create function of this part of the tutorial. Yes, last command buffers. Void. Creating semaphores by filling in the VK create semaphore create info, but the current version of the API doesn't actually have any required fields besides the S type. Cool. Future versions of the Vulkan API or extension may add functionality for the flags and PNX parameters like it does for the other structures. By creating a fence requires filling in the VK creates fence info. Creating semaphore and fence allows the familiar pattern with VK create semaphores.
Oh my god, Jenny!
To create semaphores. Cool. The semaphores and fence will be cleaned up at the end of the program. Yep. Onto the main drawing function. Finally, we can draw this shit. Waiting for the previous frame. At the start of the frame, we want to wait until the previous frame has finished. So the command buffer and semaphore are still available to use. To do that, we call a VK wait for fence. First, we wait for the fence to see if it's available. Okay. VK wait for fence function takes an array of fences and waits on the host for either any or all fences to be signaled before return. The VK true we pass here indicates that we want to wait for all the fences, but in the case of a single one, it doesn't matter. This function has also a timer parameter that sets the maximum value of a 64-bit unsigned integer, which effectively disables the timer. After waiting, we need to manually reset the fence to the unsignal state with the VK reset fence. Cool. Okay, the cat is not jumping on my finger, sadly. Also, good, I don't fucking know. Before we can proceed, there is less hip hop in our design. On the first frame call, we call draw frame, which immediately waits on the in-flight fence to be signaled. In-flight fence is only signaled after frame has finished entering. And since this is the first frame, there are no frames in which to signal the fence, thus VK for fence definitely waiting on something which will never happen. One of the many solutions of this dilemma is a clever workaround bit directly. Create a fence in the signal state, but the first call to VK wait for fence returns immediately. Let's create signal bit, create sync objects. Cool. Acquiring an image. Next, we need to draw in the draw frame. Function is to declare image for swap chain. Recall that swap chain is a convention feature, so we must use a function with the VK KHR convention. I'm so confused. I'm just gonna. Yeah, we wait for fences. Change there. The first two parameters of VK acquire next image KHR are the logical device and the swap chain from which we wish to acquire the image. The third parameter specifies a timeout in nanoseconds for an image to become available. Using the maximum value of a 64-bit unsigned integer means we effectively disable the timeout. Effective. The next two parameters specify synchronization objects that are to be signaled when the presentation engine is finished using the image. That's the point in time where we start drawing to it. It is possible to specify semaphore, fence, or both. We are going to use our image available semaphore for that purpose here. The last parameter specifies a variable to output the index swap chain image that has become available. The index refers to the wiki image in our swap chain image. We're going to use that image to pick the wiki frame buffer recording the command. With the image index specifying the swap chain image to use in hand. We can now record the command buffer. First, we call the vk reset command buffer. This recorded. So, acquire next image. We acquire the next image. Second parameter of wiki command buffer is a wiki command buffer reset flag. Since we don't want anything special, we'll leave it to 0. Understand. We'll now call the function record command buffers to record the commands we want. Record commands buffer. Cool. Submitting the command buffer. Queue the submission and synchronization. Queue submission and synchronization is configured through parameters in wiki submit info.
Yes.
The first three parameters specify which semaphore to wait on before executing begins and in which stages of the pipeline to wait. We want to wait with writing colors to the image until it's available. So we are specifying the stage of the graphics pipeline that writes to the color attachment. Okay. That means that theoretically the implementation can already start executing a vertex shader and search while the image is not yet available. Each entry in the wait stages array corresponds to the semaphore with the same index in the wait semaphores. The next two parameters specify which command buffer to actually submit for execution. Simply submit a single command buffer we have. Semaphores. The signal semaphore count and p signal semaphore parameter specifies which semaphores to signal once the command buffers have finished execution. In our case, we are using the render finish semaphore for that purpose. And the semaphore to use. Also count. Just use the reference here. I don't know. Okay, and then we submit the queue. Let's submit draw command buffer. You submit the command buffer to the graphics queue using wiki submit queue. The function takes an array wiki submit infrastructures as argument efficient. Much when the workload is much larger. The last parameter references an optional fence that will be signaled when the command buffer finishes execution. This allows to know when it's safe to command buffer to be reused, as we want to give it in-flight fence. Now, on the next frame, the CPU will wait for this command buffer to finish executing before it records the new command set. Remember that subpasses in render pass automatically take care of image layout transitions. These transitions are controlled by subpass dependencies, which specify memory and execution dependency between subpasses. We have only a single subpass right now, but the operation right before and right after this subpass also count as implicit subpasses. There are two built-in dependencies that take care of the transitions at the start of the render pass and at the end of the render pass, but the former does not occur at the right time. It assumes the transition occurs at the start of the pipeline, but we haven't acquired the image yet at that point. There are two ways to deal with this problem. We could change the wait stage for the image available semaphore to wiki pipeline stage top of the 5-bit. To ensure the render pass doesn't begin until the image is available, we can make the render pass wait for the proper stage call attachment output stage. I decided to go separate from here because it's a good excuse to have look at the subpass dependency, how they work. Create a subpass dependency. In the wiki you can instruct how to create render pass function as well. Create render pass. Okay, let's do it here. The first two fields specify the indices of the dependency dependent subpass. The special value, make a subpass external, refers the implicit subpass before or after the render pass depending on whether it is specified the source subpass or the subpass. The index 0 refers to our subpass, which is the first and only one. The DST subpass must always be higher than source subpass for any cycles of dependency graph, unless one of the subpasses is VK subpass external. Source stage mark source max. Next two fields specify the operations to wait on and the stages in which these operations occur. We need to wait for the swap chain to finish reading from the image before we can access it. It can be accomplished by waiting on the color attachment output itself. The operations that should wait on these are in color attachment stage and it will be setting of color attachment. These settings will prevent the transition from happening until it's actually necessary and allowed when we start writing colors to it.
Oh my god.
This is cool. Presentation. The last step of drawing a frame is submitting the result back to the swap chain. It eventually show up on the screen. Presentation is configured through a wiki present info KHR struct at the end of the draw function. At the end of the draw frame function, I'm sorry. Frame function. The first two parameters specify which semaphores to wait on before presentation can happen, just like wiki submit info. Since we want to wait on the command buffer to finish execution, thus our triangle being drawn, we take the semaphores which will be signaled and wait on them, thus we use the signal semaphores. I'm so fucking broken, I don't know what I'm reading. Finish execution, the start on, we take semaphores. The next two parameters specify the swap chain. Present images to and the index of the image for the swap chain, and this will almost always be a single one. Okay. There is one last optional parameter called p-result. It always allows you to specify an array of PK results values to check for every swap chain if presentation was successful. It's not necessary if you're using a single swap chain because you can simply use the return value of the present function. Present you. The VKQ present KHL function submits the queue, the request to present the image to swap chain. We'll add an error handling for both VK acquire next image and VK present queue in the next chapter, because their failure does not necessarily mean that the program should terminate, unlike the functions we've seen so far. If you did everything correct at this point, you should be able to see something. Oh my fucking god, please tell me this works. Oh fuck yeah, look at this shit. Look at this beauty. Look at this beauty. Look at this beauty. Look, look, look.
Huh?
Look at this beauty.
Let's go to Maki's stream.
You don't have to go to my stream. Thank you very much.
Triangle I have ever seen.
It's a normal.
Desktop wallpaper for me.
It's the simplest triangle ever.
But it is so beautiful.
Thank you.
I love it. See, Kitty sent it. It's the most beautiful triangle.
It's the most basic triangle ever. If I wasn't in Vulkan, I wouldn't need 20 hours to make this shit.
color. It's very beautiful.
The portrait seems a bit different from the one we used in graphic tutorials. That's because the tutorial is.
You should be proud of
Thank you,
yourself.
you too.
It's something.
So we will have considered podcast discussion the difference. He only does it. I haven't seen. Shit.
Hello.
Well, mine doesn't crash with it isn't good. That's not good. I fucked something up. I can't care. The message printed to the terminal from debug calls tells us why. Remember that all operations in draw frame are asynchronous. That means that when we exit the loop, capping is bad idea. To fix that problem, we should wait for the logical device. Makes sense. You can also wait for the operation-specific command queue to be finished with wiki wait idle. These functions can be used a very rudimentary way to perform synchronization. You see that the program now exits without problems when closing the game. Yeah. Totally didn't happen before. Nah. Me? Never.
Oh.
What errors? No errors. I don't have errors even when I need them, bruh. That's how good my code is. 900 lines of code. That's not a little, that's like 950. I mean, I probably have a few more spaces, but what the fuck? Are we fine? That's it. Final triangle. Created in object. Draw. Frame. Difference of the book, but the takeaway message is the book gives an immense amount of control through its explicitness. I recommend you take some time now to reread the code and build a mental model of the purpose of all the Vulkan objects in the program and how they relate to each other. And when I'm finished with this, I'm gonna take the code they provide, copy paste it into my code. Alright, let me test that. Let's do this. Versus some codes less. PCH. PCH to page. See there. X. It closes everything. Huh? Yeah, let's see. I wanna. So what is it? Render or something? This was causing an error before in the code they provided. It should cause it. Yes, it does. See.
That's when you can just run.
Cool. I didn't set up that correctly. Can I use this? This has good. These tools. Let's see all the differences. Okay, that's at the end. Same thing. I'm gonna move. Okay, let me do this. Or yes. I think so. We just finished this tutorial and I completed, right? Fine, I try and get myself committed so I can look around, I guess. check validation live support. I did these defaults.
Oh, it's his kid.
Yeah, that's fine. I don't think I had that before. I did. It has one, so I don't think that's the correct place for that. It doesn't matter. Let's see. It is at the end. Your messenger. Can I somehow have different scrolls for these two files? That's the main of CPP. Main what? Main tutorial. Let's copy paste everything from this one into here. And then go to main here. Just a little depth. This is what I have. How mine looks. Now you're gonna do a simple main. Main.
Oh my god.
Let's leave it at this place. I'll compare with this. Okay, I guess I have to do it this way. You don't use this. Validation layers is this. Device extensions is this. And debugging that, we use our custom ones. Create debug. Compare. Pair. Except being a bit weirder in my code. This, there is literally no difference, I feel like. Compare with clipboard. Literally no difference, okay. Cool. Destroy logger.
Oh my god. She has
Clipboard.
him. She has skin.
Your families. Top chain. Yep. Low run. Now. So we have our window.
It's better.
Short instance. Debug manager. Surface. Physical handle device. Graphics queue. Didn't use swap chain image. Chain formatting. Then. It would be weird if it wasn't the same. Int window is
Oh my god.
the same as Vulkan. Create instance, setup create surface physical. Let's see, setup debug manager. Setup debug manager. In this case. If I just did this, will there be any difference between these two? That's what. between these two. All that one, but that's because they're using different types of things here. Play debug manager, yeah, debug manager, tools here. Creators. Create instance here. Create instance here. If validation errors. Okay. For that thing. Same here, AdventOfCode structure. Hello triangle, create structure. Extensions. Extensions data. Okay, here.
What? No.
Oh, that should matter really.
Okay.
I can understand why it would matter if we were here. But it shouldn't matter since we're out there. The difference between this and this is that I can put it here because this is continuous code. This would be inside of this space. This, what's the name? This inside of this let's call it space, so it would drop and be destroyed after this. But here we don't have those, so it shouldn't be destroyed really. I'm confused if that's the case, but I don't think it is. 0 next. I wanna go to that fucking chapter and just see what how I fucked up so badly. And the thing just doesn't work. Short circuits. Okay guys, BRB.
Computers now have primary control of critical vehicle functions.